Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn about time in Pandas. In previous couple of three, four videos, we explicitly dedicated each video for one was for pd.timestamp, then we did pd.to datetime, date range, and so on and so forth. In this video onwards, what we are going to do is use those commands and few other commands to look at how we can manipulate the time data. So there may be some repetition from the examples that you have already seen, but bear with me, this is going to be really interesting, and we'll look at how to look at data from different angles. So let's get into it now. In this video, we'll look at how to create date time from different time formats. We'll look at how to create date ranges, and I'll mention what is naive versus aware time. Basically, naive time is which is not associated with any time zone, and aware time is when we add a time zone to a timestamp. So we'll look at that, and then we'll also look at how to use datetime as index, and then moving further, how to use that datetime index to do group by manipulations such as mean, and we'll look at how we can add numbers or days to a particular timestamp. So let's get into Jupyter Notebook and start coding. Here I've already imported two libraries, NumPy and Pandas, and for versions I've added those as well. So if you are on a different version, then it may be possible that some of the commands may work differently on your computer. So the first item that we are going to look at today is how we can convert different formats to Pandas time format. So how do we work with different formats? And if you remember from the previous videos, we looked at pd.to datetime, and this is very versatile, and we can specify different types of datetime formats, and it will convert all of them first. So let's say we could provide a string, so 2020-07-13, or we could have another format which is in NumPy, datetime 64. So datetime 64, and here again we can specify the same string 13, or we could use the base Python datetime.datetime. And I forgot to mention here, we also need to import datetime library because we are using that right here. So datetime.datetime, and the way we specify the numbers here is the year, then followed by the month, and then followed by the day. So when we run this, what we get is a datetime 64 that pd.to datetime has converted for us. Now here if you notice, this automatically gets converted to a datetime index. Okay, so and the frequency is none, and the data type is in nanoseconds, datetime 64. Next, let's look at date range. We'll go in further detail in a future video, but here let's look at one example of that. So if we create a variable x and assign it to this pd.date_range, and here we can specify the date as a string, so 2020-07-13, and we can specify how many ranges, how many time points do we need. So that can be specified in periods. So let's say 5 time points, and frequency is what should be the spacing between those time points. So let's say 5 hours, and when we run this, we we can see that we have created 5 time stamps, and each of them is separate. First one starts at 0 hours, and then it goes to 1000, and then from 10 to 20, sorry, 5 to 0 to 5, then 5 to 10, then 10 to 15, and 15 to 20 finally. So that's how we can create date range. Next, let's look at how we can localize time. So by localizing, I mean that if we have a time stamp that does not have a time zone associated with it, then it is considered as naive time. So naive is without time zone, and then aware time is with time zone. So if we want to, so the time that we have up above here, that's naive time because it does not have a time zone associated with it. What we can now do is add a time zone to it, and to do that we'll use the variable x because it already has those timestamps, and then we can specify x dot tz underscore localize, and then tz is equal to, within quotes, capital UTC. And what this does is we are assigning the coordinated universal time UTC to that particular those timestamps. So as you can see now, we have the UTC time specified here in the data type. Okay. Similar to this, we could specify other time zones as well. So for example, tz underscore localize, tz is equal to, here we can specify Asia backslash Kolkata, and when we run this, now we see that it is localized to this particular time zone. And finally, let's look at one more, tz localize, tz is equal to America Los Angeles, and again we can see that now this time zone these timestamps are now localized to this particular time zone right here. So the reason why we would need to localize is, let's say if we have data points for customers from different parts of the world, and they are in naive time without the time zone information, then if we want to collectively combine them and work with them, we would need to convert them to local times to know what time of day they are working. And we can then, if we are trying to mix data from, let's say, one country, US and India, let's say for example, then the day and night cycles would be different. But when we convert them into the let's say UTC, then we would be able to match exactly at what time points what's happening. Next, let's look at datetime in datetime as index. So datetime as index, and we'll in coming videos we'll look at some real life examples, so get more intuition about how these work. We'll use the same variable x. Now to this we'll assign the date ranges this time. So x is equal to pd dot date underscore range, and we'll use the date 2020-07-13, and periods, let's say 5, and frequency we'll put 1 hour frequency this time. So either you could type just h or 1h, and then we'll name it, let's name it as time with double E. And when we run this is the date range that we have created, where the frequency now is based on 1 hour interval. So So we go from 0 to 1, and then here we are going to 1 to 2, then 2 to 3, 3 to 4, and we now also have the name time with double E for this datetime index. This now the interesting part is when we want to use this date range within a series, it gets automatically added as a datetime index. So let's try that. XS, which is a series, then pd.series, then np.random integer. Let's say integer, we start at 1, go up to 6, and we need 5 data points there. Here we can specify. Now if we run just this, we know that it's going to be numeric indices. Now we go ahead and say index is equal to x, then we have added the timestamps as indices for this particular series. And there are several important uses of timestamps. Let's say one of them is we can combine information from different time periods. So let's say if we want to resample, how do we do that? If you want to resample hourly information, say xs.resample, and from this, if we would like to find what is the mean value of these numbers right here on a 2-hour interval. So the way we would write that is x.resample, open parenthesis, within quotes you want to type 2h, close quotes, close parenthesis, and then we type mean. And now we have the mean based on 2 hours. So the first hour would be 0 to 2, and the numbers there are 3 and 1. So the mean is 2. Then the second one goes from 2 to 4, and the numbers there are again 3 plus 3, 6, divided by 2 we have 3, and the last one is just 4 there, so we have 1 as the mean. You're probably wondering, can we use GroupBy, which we looked at in previous videos? Yes, definitely. So let's try that as well, how we can use GroupBy along with the time series. And I'm gonna pull the time series again right here. So what we can do is type x dot, and because this has a timestamp, we would need to use grouper. So GroupBy, and within square brackets we are going to specify pd.Grouper and open close parenthesis, and within this parenthesis we want to specify the level. So the index is at level 0, and we just have that one. Frequency will keep the same frequency 2h, so we can match with previous result, and then we'll again get the mean. And as you can see, we get the same output 231, and here also we get 231. Now let's look at how we can work with time series in our data frame. So I'm gonna go ahead and add the same series that we have right here to our data frame. So data frame time series, and let's create df as the data frame. So df is equal to pd.DataFrame, and here I'm going to create a column A which has the series XS, and then I'm creating another column B which has the series X, same series. I'm going to multiply the values in that series by 2. And so the final data frame that we have looks like this. So we have the same series A right here, and B is the double of that, and of course we have the time index. So we can now use these time indices to do a group by. So to do that, what we would do is type df.GroupBy, and again we are going to use the pd.Grouper, and open close parenthesis, and within it we'll specify level is equal to 0, frequency is equal to, say, 2 hours, and again we are going to get the mean. So this time we have the mean for column A, which is the same as previous result 231, and we also now have the result for column B calculated right here. Now what if we want to group by only column, if we want to group by using the index time as well as A column? How do we do that? So for that we would type df.GroupBy and then pd.Grouper level is equal to 0, frequency is equal to 2h, and here where we are specifying level is equal to 0, we can also directly write the name of the index. So here I'm putting time with double E, and after the parenthesis within the square brackets we can specify name of the column that we want to use. So here I've specified column A, and then we can specify dot mean to calculate the mean. So as you can see, we now have the output where the group by is based on index as well as the column A, and thus we have the mean results for column B calculated. Next, let's look at a very simple arithmetic that we can perform with timestamp. Arithmetic with timestamp. So let's create a timestamp X timestamp which uses a string 2020-07-13, and if we look at this is the timestamp we have. Now what if we want to change this and add a 1 day to this timestamp, so that the final day would be 2020-07-14? The way we would do that is type x, so I'm going to create another variable y. So x plus pd.to_time delta. If you remember from previous video, we need to convert the number or integer to a time delta value. So in this case we are converting it to 1 day, and then now this would now represent a day which can be recognized and added to this timestamp X that we had created earlier. So this is how we see that we have added 1 day there. Here if we look at the day of the week, just to check day underscore name, so we see that 13th is a Monday, and then if we look at y day underscore name, this would now be a Tuesday. So I hope in this video you have learned how to combine different time formats using to_datetime, what is knife time and aware time, and how to make a knife time into aware time by assigning it a time zone. And then we also looked at how to create date ranges, how to resample and group data based on time index. In next video we'll continue this discussion in time series and look at few more examples. Please like, share and click the bell icon below to subscribe. I hope to see you all in the next video. Thank you.